Hello everybody, this is Mr. McNair, and this is a video on the 2007 OGT questions that had to do with geometry and spatial sense. So, if I were you, I would go ahead and take a moment and pause the video and just kind of read through these tips. Alright, number 6. This one says the net creates a pyramid. The net creates a pyramid. Which pyramid does this net create? Now, when you're dealing with a net is something, it's a figure that you could fold into a three-dimensional object. Now, on the base of this net, we see that this base is a circle. So what I would do in this problem is I would go through, look at all the choices and eliminate the ones that don't make sense or couldn't be that possible figure. So, for example, we said that once again this circle is on the base, so I can eliminate anything that doesn't have a circle on the base, like D. Other things that I might notice are that these squares, those are opposite each other. So when I fold that net in, those aren't going to be touching each other adjacently. So I could automatically eliminate A because the squares here are touching. Also, I could look at this triangle here and these double lines, and those are opposite each other. So adjacent wise, those aren't going to be touching either. So I can eliminate C then. So my only logical choice then would be B. Okay, and then also you can look and see that here the triangle is adjacent to the square. So because and when you fold this net in, you would be able to see that the triangle and the square should be adjacent to each other. Okay. Before we go on to the next question, I do want to talk about prisms. A prism is something that has two bases. Okay, and everything else that are surrounding the bases are called the faces of the prism. So here we have a triangular prism in particular. So that means that the bases are going to be triangles. So notice we have these two triangles, okay, here and here. And everything that surrounds those are going to be the faces, and they're usually rectangular or quadrilateral. So we have then three rectangular faces. Here we have a rectangular prism, so we have the rectangular bases, and then once again everything else are the rectangular faces. Alright, and this one is kind of hard to tell which was the face and which one is the base because it's a rectangle, so everything is going to be rectangular. But here in this pentagonal prism, you can see that, okay, we have once again a pentagon, two pentagons as the bases, and then everything that surrounds it, you have five rectangular faces. So here you had five faces, here you had four faces because it's rectangular, here you had three faces because it was triangular. Alright, let's move on to the question. So number 10, the diagram below shows two of the faces of a prism. So these are just two of them. Ellen is constructing this triangular prism out of cardboard. Ellen plans to draw a net of the prism on a piece of cardboard that she can cut out and fold to make the prism. In your answer document, sketch a net of the prism that Ellen could use. Place the dimensions on the net. So I'm going to go ahead and draw this triangle that Ellen put. So she had a 3, 2, 3, 4 triangle here. So let's try to make it look similar to hers. That does not look similar to hers at all. Alright, let's go like this. Alright, so there is my little triangle. I'm going to make another one here. Because once again, if this is going to be a triangular prism, I'm going to have two triangles, okay, because those are my bases. Now everything else again has to be the face. So let me go ahead and put my measurements in here. So this will be 2, this will be 3, this will be 4, this is 2, 3, this is 4. So I'm going to go ahead and connect. If I have two triangular bases, that means that I'm going to have how many faces? Well, because there's three sides, that means there has to be three faces. So I'm going to go ahead and connect here. Let's go ahead and move this up so this meets up a little bit better. Okay, there we go. So there's one of my faces. And then I'm going to need another face that's going to go along with this side here. So I'll put that here. So this is 2. And then I'm going to need another face that's going to go along with the 4. So I'm going to draw that here. And this side is 4. And once again, these are all 7. Alright, so then when I fold this in, I should be able to make a nice triangular prism. Alright, number 25. In which figure is the measure of angle 1 not equal to 60 degrees? Well, let's go through these and eliminate the ones that it couldn't be. So we want to know which of these has an angle 1 not equal to 60. Now, in this first one, notice that we have a line here. And the number of degrees in any line should add up to a total of 180. So here you have 60 here and 50 here. So far you have a total of 110. Well, how many more do I need to get to 180? Well, I need 70. So that means angle 1 was 70 degrees. So it looks like so far that A would be the answer. But let's keep going and make sure that that's true. So in part B, notice that we have this little box here. That means that this is 90 degrees. The total is 90 degrees. So we already have 30 here, so the rest of it has to be 60 degrees. So that one does equal 60. Here, once again, we have this line. And in any line, we have a total of 180 degrees. So already we have 120 here. So the rest of this has to be 60 degrees, because 120 plus 60 gives us that 180. All right, here we have 120 degrees here, which means because these are vertical, that this has to be 120. All right, and then also, if the problem really assumes that these two lines are parallel, by alternate interior angles, this has to be 120, and this has to be 120. So that means that this angle here, angle 1, has to be 60. Okay, because this whole thing has to add up to 180. All right, so in B, C, and D, all the angles were 60, so A is the one that is not equal to 60. All right, number 29. Points E, F, G, and H are midpoints of the size of a quadrilateral, A, B, C, D. So if AC is 12, so I'm going to go ahead and draw this in here. AC, this whole thing, is 12. Okay, and BD is 8. So this here, this whole thing is 8. BD is 8. What is the perimeter of the quadrilateral EFG? Well, seeing that this one I would actually look at, and I would start just eliminating things that don't make sense. Okay, so this problem, I already know that this whole thing, this whole blue line is 8. And that red line cuts the blue line in half. So these are both 4. That being said, this portion, here I'll put in a different color, this portion is 4 right here. Now, because that portion alone is 4, I would start kind of eyeing things. Okay, this is 4, this is the same length as that, and that. So these are all 4. All right, so automatically I know that I can cancel out D. And then then the red line, that whole thing was 12. So that being 12, this looks like it's probably going to be half of that, because we're usually dealing with the midpoints. Okay, so this is going to be 6 and this is 6. So if I add up my total size, I have 4, 6, 4, and 6. So that's a total of 20. All right, before we go into the next problem, let's go ahead and talk about pyramids. A pyramid is something that has a base of a figure, and everything else is triangular, and then it goes up to a point. Like here we have a triangular base, and then we have triangular faces all meeting at this point. Here we have a rectangle for the base, and all the rest of them triangles meeting up to a point. Here we have a pentagon for the base, and all of the other things are triangles that meet up to a point. So the figure shows a three-dimensional object when viewed from above. Which of these objects could the sketch represent? So could it be a pentagonal pyramid? Well, that means that the base would have to be a pentagon. And right now we have a base that looks rectangular or even square. So we're going to go ahead and cancel that one out. It can't be a pentagonal pyramid. Could it possibly be a rectangular prism? Well, prisms, if we go back, prisms have rectangular sides. Okay, rectangular faces. So this one doesn't have rectangular faces. It has these triangles in it. So we automatically know it can't be a prism. It has to be at least a pyramid. So I can eliminate B and D. So here I recognize that it is a triangular, or excuse me, a square pyramid, because we have a square base, and all the other sides are these triangles. Here, I'll highlight them in different colors, the triangles here. So we have a triangle here. So these are all of my triangular faces. Okay, great. Number 37, the quadrilateral below is to be translated 6 units to the right and 3 units down. Which order pair is not the coordinates for the vertex of the translated image? So we could take these points and go 6 units to the right and 3 units down. So let's take them one at a time. This we go to the right 6, 1, 2, 3, 4, 5, 6, and then 3 down, 1, 2, 3. And then let's go with the next point. Here we're going to go to the right 6, 1, 2, 3, 4, 5, 6, and then down 1, 2, 3. Let's take our next point, go to the right 6, 1, 2, 3, 4, 5, 6, down 3, 1, 2, 3. And then let's take our last point and go to the right 6, 1, 2, 3, 4, 5, 6, and then down 1, 2, 3. So here is our figure, our new figure. All right, so let's go through and see which order pair is not on one of the coordinates. So 3, negative 4, is that on our graph? 3, 3, negative 4. 1, 2, 3, 4. That is. So that's not the answer. 3, negative 1. 3, negative 1. That's here. That's not on our point, so that's it. Let's make sure, though. Let's go through the rest of our points and make sure they're on our quadrilateral. 3, 2 is, and 1, negative 1 is also. All right? So those couldn't be it. All right, let's go to the next one. Jake is using a computer program to design parts for a new car. He has outlined one half of a part on a coordinate grid. Rather than drawing the second half, he plans to have the computer reflect this shape over the y-axis. Which of the following represents the 5 vertices of the reflected shape? So let's go ahead and just reflect it. Remember, reflecting something is going to make it look exactly, or the mirror image of the original figure. So this line here, I'm going to reflect it over the y-axis. And once again, this is our y-axis. Okay, and they have it labeled for you. Alright, so we're going to reflect it. It's 1 unit long, so there's that. Here we're going to go from here. It's 2 units away from the y-axis, so we're going to put it 2 units away from on the other side, so that's there. And here we're also 2 units away, so we're going to do that on our y-axis, put that 2 units away. So our figure is pretty much just going to look like this. Okay? So, which of these following represents the 5 vertices? So, we have, on our vertices, we have 0, 0. We have negative 2, 0. Remember, your vertices always go x first, y second. Here, we have negative 2, positive 2. We have negative 1, positive 3. And then we have 0, 3. So let's look through and see which one of these match up. So 0, 0, 0, 2. This couldn't be that one because 0, 2 is not our point. 0, 0, 0, 3, negative 1, 3, negative 2, 2, and negative 2, 0. It looks like it's this one. But just to make sure, let's keep going. 0, negative 3 for 0, 0 for C. 0, negative 3 is not a point on our graph, so it's not C. And D also has 0, negative 3, which is not a point on our graph. So B is our answer. Alright, hopefully this video has been helpful to you, and have a great day.